Good morning, friends. So this is in the continuation of the calculation of warping machines. So here in this lecture I am going to discuss about the calculation of beam warping and sectional warping. So in this we will discuss reed width, tape length, creel capacity, section width, number of warpers beam required, etc. So we will start with the beam warping machine. As you all know that in case of beam warping machine, the outcome is warpers beam, and the warpers beam have fraction of ends in a single warpers beam, but the width of warpers beam is equal to weaver's beam. So in case of beam warping machine, the width of warpers beam remains same as weaver's beam. So we will start the calculation with a small example. So here I'll write down some of the fabric particulars, and then we will calculate reed width, tape length required, number of warpers beam required. So here calculate the number of warpers beam required, reed width, and creel capacity from following fabric particulars. So the fabric particular is width of fabric. Here we can take 54 inches. Length of fabric, you can take 5000 meter. Creel capacity, (600 ends), or you can say cone holders. So in creel we can keep 600 cones. So now we have to and the ants per inch, let's say it is 62 ants per inch. Now we have to calculate the reed space, reed width, creel capacity, tape length. So I'll write down here reed space or reed width, tape length, creel and number of warpers beam. So we have to calculate all these things: reed space 1, tape length 2, free 4, number of warpers beam. So as you all know, reed space or reed width we can calculate by adding crimp in the fabric width. So here we can assume that the crimp in warp and waft is 5%. So crimp in warp and waft is 5% we have taken. So reed space is fabric width one plus crimp, that is reed space, and tape length is fabric length 1 plus crimp by 100. Because we have taken both the things, crimp in warp and waft 5%, so we have we in the calculation we are adding crimp in both of the cases, reed space and tape length. If the crimp is different, then in case of reed space we will add crimp of waft. In case of tape length we will add crimp of warp. So this is crimp of waft and this is crimp of warp, but in our case both are same, so we are adding crimp in case of reed space and in case of tape length. Now the creel. So here we have the creel capacity 600. So first of all we will calculate total number of ants. So total number of ants can be calculated by the fabric width multiply by ants per inches. So here we have fabric width in inches and we have EPI. So when we multiply fabric width with EPI, so it will give you total number of ants. So now we will calculate reed space, tape length, total number of ants, and then we will calculate creel required and then number of warpers beam. So reed space. So here we have fabric width 54 inches and crimp 5%. And that is equal to this comes 56.7 inches. So this is our reed space. Tape length, so length of fabric 5000 meter plus crimp, that comes 5250 meters. Now the total number of ants, fabric width multiply by EPI, that is 54 multiplied by 62. So that is 3348 number of ants. Now the creel, the total capacity we have 600 and we have total number of ants 3348. So now we will find out how many number of Warper's beam we have to produce, because total number of ants are much higher than creel we have. So here we have only 600 ants available, but we have to produce a weaver's beam with the total number of ants of 3348. So now we will find out how many ants we can accumulate in one Warper beam. So we have 3348. Now we will divide it with the 600, which is our maximum creel capacity. This is the total number of ants and this is our creel capacity. So this is coming around 5.58. So approximately we have to produce 6 Warper's beam. So here we can write down total number of ants divided by our creel capacity. This gives us 5.58, which is nearly equal to 6. So number of Warper's beam required 6. So now we will divide 3348 by 6. So here we are getting total number of ants divided by 6. So this gives us 558. This is the number, this much number of ants we require in one Warper's beam. So here we will not use our maximum creel capacity, we will use 558 as our creel capacity to produce single Warper's beam. Now by combining all these 6 Warper's beam, when we combined all these 6 Warper's beam, so we will get a weaver's beam with the capacity of total 3348 ants. So this way we can produce a Warper's beam in beam warping machine. Thank you. So in my next lecture I will discuss about the read space, sectional width, number of ants in one section, and we will do other calculations of sectional warping machine. Thank you.